Section 14 of National Geographic Magazine, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Maria Lupe LeBlanc, Raleigh, North Carolina. An Expedition to Mount St. Elias, Alaska, by Israel C. Russell. Part 3. Sketch of the geology of the St. Elias region. General features. In the preceding narrative, many references have been made to the character of the rocks and to the geological structure of the region explored. It was not practicable during the journey to carry on detailed geological studies, but such facts as were noted are of interest for this reason, if for no other. They relate to a country previously unknown. My reconnaissance enabled me to determine that there are 3 well-defined formations in the St. Elias region. These are 1. The sandstones and shales about Yakutat Bay and westward along the foot of the mountain to Icy Bay, named the Yakutat System. 2. A system of probably later date composed of shale conglomerate, limestone, sandstone, etc., best exposed in the cliffs of Pinnacle Pass and along the northern and western borders of the Samovar Hills, and named the Pinnacle System. 3. The metamorphic rocks of the main St. Elias Range, called the St. Elias Schist. Yakutat System. The rocks of this system are of gray and brown sandstones and nearly black shales. They are uniform in lithological character over a large area, and are usually greatly crushed and seamed. So great has been the crushing to which they have been subjected that it is difficult to work out a hand specimen with fresh surfaces. Fragments broken out with a hammer are almost invariably bounded by planes of previous crushing, and are usually somewhat weathered. These rocks form the bold shores of Yakutat and Disenchantment Bays, and were the only rocks seen along our route from Yakutat Bay to Pinnacle Pass. The whole of the Hitchcock Range is composed of rocks of this series, as are also the Che Hills, and the hills west of Icy Bay, and the southern portion of the Samovar Hills. North of Pinnacle Pass there are rocks undistinguishable lithologically from those about Yakutat Bay. These are exposed in Mount Owen and on each side of Dome Pass. They also form the bold spurs about the immediate bases of Mount Augusta, Mount Malaspina, and Mount St. Elias. In the 3 instances last named, these rocks dip beneath the schist forming the crest of the St. Elias Range, and it is probable that a great overthrust there took place before the formation of the faults, to which the present relief of the mountains is due. All the mountain spurs of Mount Cook, so far as is known, are composed of sandstones and shales of the Yakutat series, with the exception of the Pinnacle Pass cliffs. Nearly all the debris on the glaciers from Disenchantment Bay to the Seward Glacier, and probably beyond, is derived from the rocks of this system. The distribution of the rocks from which the debris was derived may be ascertained in a general way, by tracing out the sources of the glaciers. Medial moraines in the Hayden and Marvine glaciers, however, have their sources in the northern slope of Mount Cook, and are composed of gabbro and serpentine. These rocks were not seen in place, and their relation to the Yakutat series can only be conjectured. Although the rocks of this system are stratified, it is impossible to determine their thickness, for the reason that they have been greatly crushed and overthrust. This is well illustrated in the Hitchcock Range, which, as already explained, trends about northeast and southwest, and is composed of strata of shale and sandstone, having a nearly east and west strike and a uniform dip toward the northeast. Were the rocks in normal position, their thickness would be incredible. In addition to this negative evidence, there is the crushed condition of the strata to show that movement has taken place all through their mass, and in a few instances thrust faults were distinguished dipping northeastward at about the same angle as the lines of bedding. In the crushing to which the rocks have been subjected, the shales have suffered more than the sandstones, and have been drawn out into wedge-shaped masses, the sharp edges of which usually point toward the northeast, which is presumably the direction from which the crushing force acted. The hypothesis that the rocks in the St. Elias region have been crushed and overthrust explains many otherwise inharmonious facts, and accounts for the superposition of the St. Elias schist upon rocks of the Yakutat system. Coal has been discovered in the rocks of the Yakutat system about 2 miles west of the southern end of Disenchantment Bay, and is reported to be of workable thickness. I saw thin lignite seams at the surface of this locality, but as the shafts were filled with water, I was unable to examine the coal in the openings and cannot vouch for its thickness. Samples obtained from the mine show it to be a black lignite, which would apparently be of value for fuel. Fossil leaves are reported to occur in connection with the lignite, but these have never been seen by anyone who could identify them. The rocks of the Yakutat system, wherever seen, dip northeastward except when greatly disturbed near fault lines. East of Disenchantment Bay, the inclination of the beds is from 15 degrees to 20 degrees. Farther westward, the dip increases gradually all the way to the Hitchcock Range, where the prevailing inclination is from 30 degrees to 40 degrees, and frequently still greater. Beneath Mount Malaspina and Mount St. Elias, the Yakutat sandstones dip northeastward at an angle of about 15 degrees, and in the hills west of Icy Bay, the dip is about the same. Exceptions to the prevailing dips occur along the immediate shore of Yakutat Bay, northwest of Knight Island, and at the southern extremity of each of the mountain spurs between Yakutat Bay and Blossom Island. At these locations, the rocks are frequently vertical or nearly so, owing their high dip to the proximity of lines of displacement. The faults indicated by these unusual dips also mark the boundary between the mountains and the seaward stretching plateau of alluvium and ice. The crushing, overthrusting, and faulting that has affected the rocks of this system render it doubtful whether the coal seams which occur in it, even if of requisite thickness, can be worked to advantage. Some of the samples of coal obtained at the openings made near Yakutat Bay were slicken-sided, showing that movements in the coal seam had there taken place. As already stated, the rocks of the Yakutat series are remarkably uniform in character throughout the extent now known, and offer but little variety. The sandstones are intersected in every direction by thin quartz seams, which stand in relief on the weathered surfaces, giving the rocks a peculiar and characteristic appearance. The first important change in the geology along the route traversed by us was met on reaching Pinnacle Pass. Pinnacle System. The rocks of this system, as already stated, are best exposed in the great fault scarp forming the northern wall of Pinnacle Pass. They are more varied in composition and have preserved a better record of the conditions under which they were deposited than the sandstones and shales of the Yakutat system. Only an approximate section of the rocks exposed in the Pinnacle Pass cliff was obtained. Sandstone and conglomerate weathering into spires, 500 feet. Evenly bedded, sandy shale in thin layers, 600 feet. Coarse conglomerate, boulders of crystalline rock, 50 feet. Thinly bedded, dark-colored sandstone and shale, 500 feet. Reddish conglomerate, 10 feet. Light gray sandstone with thin irregular coal seams, 40 feet. Total 1,800 feet. There is also a compact crystalline gray limestone near the upper portion of the series, which escaped notice in the cliffs. At the end of the Pinnacle Pass cliffs, however, where the rocks are turned northward by the great fault which decides the course of the Seward Glacier, and dip eastward at a high angle, the limestone is well exposed and has a thickness of about 50 feet. In many places, the surface of the layers are covered with fragments of large pecten shells. Associated with the limestone, there are reddish shales, much crushed and broken, and a peculiar conglomerate. The pebbles in the conglomerate are of many varieties and were observed at places along the Pinnacle Pass cliffs. Their most marked peculiarity lies in the fact that they have been sheared by a movement in the rocks and sometimes broken into several fragments, which have been reunited, probably by pressure. These faulted pebbles are characteristic of the strata from which they were derived. Similar pebbles were afterward obtained in the Marvine Glacier near its junction with the Malaspina Glacier, thus indicating that there are other outcrops of the conglomerate about Mount Cook, near where the Marvine Glacier has its source. Two quartz pebbles from the conglomerate of the Pinnacle Pass are shown in the accompanying illustrations. The larger pebble, shown in Figure 7, is of bluish-gray quartz, and the smaller one, depicted in Figure 8, is of white quartz. The fragments into which they have been broken are now firmly united. The engravings are photomechanical, Moss process, reproductions from the objects. In the northern and western part of the Samovar Hills, the rocks of the Pinnacle system again appear, forming a bold angular ridge, curving southward and reaching the border of the Agassiz Glacier. The southern face of this range is precipitous, and, like the Pinnacle Pass cliffs, exhibits the edges of northward dipping strata. Its northern and western slopes are heavily snowbound. It is in reality a continuation of the Pinnacle Pass fault, but thrown out of line by the cross fault which marked out the course of the Seward Glacier. Figure 7. Faulted pebble from Pinnacle Pass. The Yakutat and Pinnacle systems are so easily recognized that the distribution can be distinguished at a glance, when the outcrops are not concealed beneath the nearly universal covering of snow. The rocks of the Yakutat series are heavily bedded sandstones and shales, and have in general a light brown tint, while the rocks of the Pinnacle series are thinly bedded and dark in color, appearing black at a distance. The presence of pectin, Patinopectin corinus, Gould, in the limestone of the Pinnacle series has already been mentioned. Other fossils were obtained from sandstones and shales at the crest of the cliffs above Pinnacle Pass at an elevation of 5,000 feet. These were submitted to Dr. W. H. Dahl, who kindly identified them as follows: Maya arenaria Linnaeus, Mytilus edulus Linnaeus, Leda fossa Baird or Linnaeus Vianuta Faber, Macoma inconspicua Broderick and Sowerby, Cardium islandicum Linnaeus, Litorina atcana Dahl. All of these species are stated by Dahl to be still living in the oceanic waters of Alaska. The very recent age of the rocks in which they occur is thus established. Figure 8. Faulted pebble from Pinnacle Pass. In strata closely connected with the layers in which these shells were found, there occur many fine leaf impressions, a few of which were brought away. These have been examined by Professor L. F. Ward, who has identified them with 4 species of salix, closely resembling living species. The report on these interesting fossils forms Appendix D. The age indicated by both invertebrates and plants is late Tertiary, Pliocene, or early Pleistocene. This determination is of great significance when taken in connection with the structure of the region and shows that the mountains in the St. Elias region are young. Not only was a part, at least, of the Pinnacle system deposited during the life of living species of mollusks, but also the whole of the Yakutat series, the stratigraphic position of which is, if my determination is correct, above the Pinnacle system. After the sediments composing the rocks of these 2 series were deposited in the sea as strata of sand, mud, etc., they were consolidated, overthrust, faulted, and upheaved into one of the grandest mountain ridges on the continent. Then, after the mountains had reached a considerable height, if not their full growth, the snows of winter fell upon them, and glaciers were born. The glaciers increased to a maximum, and their surfaces reached from 1,000 to 2,000 feet higher than now on the more southern mountain spurs, and afterward slowly wasted away to their present dimensions. All of this interesting and varied history has been enacted during the life of existing species of plants and animals. The relative age of the Yakutat and Pinnacle series is the weakest point in the history sketched above. The facts on which it rests are as follows. At Pinnacle Pass, the sandstones and shales forming the southern wall belong to the Yakutat system and are much disturbed, while the northern wall, or the heaved side of the fault, is composed of the rocks of the Pinnacle system inclined northward at an angle of 30 degrees or 40 degrees. North of this fault scarp, in the foothills of Mount Owen, sandstones and shales, seemingly identical with those of the Yakutat system, again occur, although their direct connection with the rocks south of Pinnacle Pass was not observed owing to the snow that obscured the outcrops. Again, at Dome Pass, a similar relation seems evident, but cannot be directly established. The immediate foothills of Mounts Augusta, Malaspina, and St. Elias are also of sandstone, lithologically the same as the Yakutat series. The conclusion that the Yakutat system is younger than the Pinnacle Pass rocks was reached in the field after many other hypotheses had been tried and found wanting, and to my mind it explains all the observations made. Even should the supposed relations of the two series under discussion be reversed, it would still be true that a very large part of the rocks of the St. Elias region were deposited since the appearance of living species of mollusks and plants, and that the prevailing structure of the region was imposed at a still later date. This will appear more clearly after examining the structure of the region. St. Elias schist. The rock forming several thousand feet of the upper portion of the St. Elias range is a schist in which the planes of bedding are preserved. The dip of the strata is northeastward and has exerted a decided influence on the weathering of the mountain crests. As the opportunities for examining this formation were unsatisfactory, a detailed account of it will not now be attempted. Geological structure. The abnormal thickness of the Yakutat series, due to crushing and overthrust, has been referred to, as has also the superposition of the St. Elias schist upon rock supposed to belong to the Yakutat system. The plane of contact between the sandstone and the overlying schist of the St. Elias range dips northeastward at an angle of about 15 degrees, corresponding as nearly as can be determined with the dip of the strata in the sandstone itself. All of the observations made in this connection indicate that the schist has been overthrust upon the sandstones. After this took place, the great faults to which the range owes its present relief were formed. About Mount Cook, however, and in the elevated plateau east of Yakutat Bay, the conditions are different from those observed along the base of the St. Elias range. The only displacements known in the Yakutat system south and east of Pinnacle Pass is the Great Fault, which presumably exists where the rocks of the foothills disappear beneath the gravel and glaciers of the Piedmont region. The faults referred to belonging to the same series as those which determine the southern and southwestern borders of the St. Elias range and many of the foothills south of the main escarpment. Besides the great faults which trend from St. Elias toward the northeast and northwest, there are several cross faults, one of which determines the position of the Seward Glacier through a portion of its course, while another marks out the path of the Agassiz Glacier, and two others may be recognized just east of the summit of St. Elias, which have dropped portions of the eastern end of the orographic block forming the crowning peak of the range. The southern face of Mount St. Elias is a fault scarp. The mountain itself is formed by the upturned edge of a faulted block in which the stratification is inclined northeastward. As has just been mentioned, the mountain stands at the intersection of two lines of displacement, one trending in a northeasterly and the other in a northwesterly direction. The one trending northwestward extends beyond the end of the northeast fault. The point of union is at the pass between Mount St. Elias and Mount Newton. The upturned block, bounded on the southwest by a great fault, projects beyond the junction with the northeasterly fault. It is this projecting end of a roof-like block that forms Mount St. Elias. That this is the case may be clearly seen when viewing the mountain from the glacier near the base of Mount Owen. Such a view is shown on Plate 20. The crest line of St. Elias extends with a decreasing grade northwestward from the culminating peak, and the northern slope of the ridge is the surface of the tilted block. From what has been stated already, it will be seen that the St. Elias range is young. Its upheaval, as indicated by our present knowledge, was since the close of the Tertiary. The breaking of the rocks and their upheaval is an event of such recent date that erosion has scarcely modified the forms which the mountains had at their birth. The formation of glaciers followed the elevation of the region so quickly that there was no opportunity for streams to act. The ice drainage is consequent upon the geological structure and has made but slight changes in the topography due to that structure. About Mount Cook and in the elevated plateau east of Yakutat Bay, there has been deeper erosion than about Mount St. Elias. The glaciers in this region occupy deep valleys radiating from the higher peaks, but whether these are really valleys of erosion is not definitely known. In some instances, changes of dip on opposite sides of the valleys indicate that they may in part be due to faulting. But owing principally to the fact that every basin has its glacier. It has not been practicable, up to the present time, to determine how they were formed. The crests of the mountains are always sharp and angular by reason of the rapid weathering of their exposed summits. But while disintegration is rapid, no evidences of pronounced decay are noticeable. The peaks on the summits of the St. Elias Range are either pyramids or roof-like crests with triangular gables. These forms have resulted from the weathering of schist in which the planes of bedding are crossed by lines of jointing. End of section 14. Recording by Maria Lupe LeBlanc, Raleigh, North Carolina.